Alright, so you just watched the Brain Pop video over seasons. We're going to create a model and a paper diagram using an online model. So, on my website, I added it on my little symbol right here. It says Seasons and Ecliptic Simulator. You can click that, and it'll bring you to this page that will let you look at the months of the year down here below. So like right now we're looking at February 10th. I can move this little guy right here to get to January 11th. Too much. There we go. So there's January 11th. And you can see this is the sun. It's pointing at the earth. Okay, but the light shines out everywhere. You can look at the earth here and you can see which side is having day and which side is having night. And you can see the tilt of the axis. Okay. So, right here, they kind of zoom in on the earth. They have it straight up and down instead of tilted at the axis so that you can see the earth and the rotation. You can grab the little stick figure guy and move him around so that you could see what it looks like on the South Pole, what it looks like on the North Pole, what it looks like at certain latitudes. So like right here, this is the equator. And we're going to leave him there. And I'm going to bring it around and you're going to watch what happens as the earth goes around. So you can either on here, you can grab the, I'm going to turn the labels on. So there's the South Pole, the Antarctic Circle, the equator, the North Pole. Okay. Then you can actually drag the earth and move it around so you can see as it goes around counterclockwise how it looks. Okay. And so you can actually see the tilt right here change or look like it changes. Okay. So right here, if you look at the model and look at right here, it tells you we're in March. This is spring. Okay. We're pretty evenly coated. Okay, nobody's closer right here because of the way that the earth is tilted. So let's look at our axis. Okay, and it's kind of leaning from the top left to towards the bottom right. Okay, and then the other thing that's important is where the equator is. Okay, the equator is going to divide us into the northern hemisphere, okay, and the southern hemisphere. So where the North Pole is, the half with the North Pole, and the half with the South Pole. Okay, so on our model, we're going to start in spring, since that's where we moved to. We're going to draw our axis. I said it was going from the top left to the bottom right, and we're going to label it, of course. That's our axis. Okay. And then we're going to draw our equator this way so we can see the equator and look at the northern hemisphere versus the southern hemisphere. So when we're talking about the seasons, we're talking about the seasons we're experiencing where we live. And that would be that we live in the northern hemisphere. So we're going to look there. Okay? Because the other seasons are going to be happening different down here. So I want you to take a green map color or colored pencil or crayon. I want you to color the top half, the top hemisphere, the northern hemisphere, green for spring. Okay? And I want you to draw this dotted line from the sun. When it lines up right where we have it, okay, that's that. Whenever you look on the calendar, you see the first day of spring is what they'll label it sometimes. Or sometimes they will call it the vernal equinox. And that's when we line up perfectly right here at this part to start spring. Okay. So all along here, we're cycling around, and the next season that we'll get to is summer. Okay. So if we go back to our model, and we're going to drag it around till we line up over here, and now we're in June. Okay. If you look over here at this model, you can look right here and see it too. It's tilted with the axis leaning towards the sun. So you can see this northern hemisphere is not a lot closer, but is getting a lot more sunlight than the southern hemisphere. Okay? So the northern hemisphere right here is experiencing summer. We're a little bit closer to the sun now, so that's why our temperatures get hotter. So we're going to go back to our paper model, our paper diagram. I'm going to draw my axis. It's leaning towards the sun now. Oops, that should have been straight. Sorry. Okay. We still have our equator. That's dividing our northern hemisphere and our southern hemisphere. Okay. But now our northern hemisphere is experiencing summer. So we're going to take our red colored pencil or our red crayon, and we're going to color the northern hemisphere red for summer. And then we're going to draw another dotted line straight across whenever we line up like we did with our model. And when it lines up right there, that's when it's marked the first day of summer, or sometimes this one's a little more heard of than the other one. This is called the summer solstice. Okay, and that's that first day of summer. So now we're going to go back. So this will be all of our summer coming around until we get right here. We're going to look back at our model, and that's going to be autumn or fall. So right here, we're going to take our planet, drag it around. We can watch the changes that happen until we get lined up. Okay, so again, it looks very similar to spring. Okay, we're kind of equally getting an amount of sunlight, so that's why the temperatures aren't way hot like for summer or way cold like we see for winter when we get around over here. Okay, so we're getting an equal amount of sunlight across the planet. Okay, so let's draw that on our paper model. Our axis, if you want to label it with just an A, our equator with an E, and of course North Pole and the South Pole, so that we're focusing on our hemispheres. And so now it's going to be fall, and I'm going to use orange and color that northern hemisphere orange for fall, for autumn. And then a dotted line, again, right when it lines up perfectly at these quarter marks, which when we're all done, you'll see the quarters that it breaks it into. This is called the autumnal equinox. Okay, so this is the equinox and this is the equinox. This is the solstice, and when you get over here, this will be the winter solstice. It's just fancy science words for marking the first day of that, when it perfectly lines up into the quarters that they've got it divided into. Okay, so we'll continue around our orbit, our revolution. We'll drag our model around, and we can watch how it changes. And then when we get perfectly lined up over here, okay, we can look and see that part of the Earth, the axis part, is tilted away. And so the bottom part is slightly closer. So it's getting more sunlight down here in the southern hemisphere than the northern hemisphere, and that's our winter. So we're going to draw our model. We've got our axis and our equator. We've got our northern hemisphere and our southern hemisphere. And now I'm going to use blue. Maybe. Where's the blue? There it is. I'm going to use blue for winter. Okay, and it's because it's a cycle, it continues on. We're going to make our orbit, make our revolution, continue our year until we get back around to spring. So this whole process of Earth revolving around the sun, okay, that's our one revolution, is about 365 days. Or 1 year. And that's when you see all the seasons. So of course, as you're at each spot and as you're going around this revolution, okay, the Earth rotates on that axis. It spins around so that while you're here, you have day and night. And you scoot over a little bit and you have day and night. Scoot over a little bit and have day and night all the way around. So the Earth will be rotating as it's going around its revolution. Okay. So, on page in your journal, you're going to glue this in. You're going to have to glue it in sideways because it's a bigger picture. Okay, you'll trim it out if you hadn't already. And you'll glue it in like this. Your title is Cycle of Seasons in the Northern Hemisphere, and you might need to scoot it over or write small because I ran out of room. Okay, we drew a little cycle symbol. Remind us that it goes around and continues. You need to put your date in the corner, and this is TEK 4.8C. Okay, 4 meaning it's a review from 4th grade, but it's something you're tested on in 5th grade. And one of the other things that we need to talk about with this diagram that we used and with the online model that we used is just a review of the fact that models have limitations. Okay. Limitations, okay, are things that can't be shown as they really are. For example, in our diagram right here, the sun and the Earth are really not that close together. On the online one, again, they're not that close together. This isn't showing Mercury or Venus. This isn't showing the moon and its revolution and rotation around us. This is only showing the revolution. It's not showing the rotation. Okay? So again, it's going to have limitations. It's going to not be able to show you every aspect of it. So what I want you to do is to list 3 limitations found with this model and tell why you think it's there. Okay, so an example would be a limit would be the size of the sun and the earth are inaccurate on this paper diagram and on the online model. The reason? Because the earth would be too small to label or color. Like we colored it here and we drew our labels, and the other one has the labels and the little stick person that we used. So that's a limit, but there's a reason. We needed to see it bigger. We needed to see, to color it in. So you're going to come up with 3 others with a limit and a reason. For this, you can talk about the paper diagram model that we drew, or you can talk about the online model. Or if you want to talk about another model that you've used before for the solar system, that's fine too. Just be sure I know what you're talking about. So you need to say with this model, with the online model, with the paper model. Okay? And be sure you tell me which one's the limit and which one's the reason.